Hi, my name is Magdalena and today I would like to show you a couple of simple experiments you can do with our Edu kit. So what you are going to need is the kit itself, the MiniPIX EDU detector, a source of alpha radiation, here I have some americium, a cling foil, some bubbles and a piece of paper. Now you're ready to get started, so you need to open the PIXED app. If you have not yet installed it, it should be on the flash drive that you received with your detector. Then we're going to set image properties. Minimum we keep 0 and maximum we make 1. We are going to use the tracking mode for these experiments, taking 1000 frames with exposure time of 0.1 seconds. The first experiment you can do is to simply watch the alpha particles from the americium and how they interact with the detector. So what you do here is just simply press play and you watch the particles that are hitting the detector. You can experiment with changing the distance from the detector. So now when we put the source closer to it, we can see that there's more radiation, and when we put it further away, we can see that we detect less and less radiation until no alpha particles hit the sensor. We can check this also in numbers because we have a little graph here on the right bottom side. When you select timeline, you can see in the blue that the amount of alpha particles was about the same. Then we put the source closer to the detector and it went up, and then we kept going further from it and further until eventually there were no alpha particles detected. Now, you have probably learned that the alpha particles are not dangerous because they are stopped by your skin. And in fact, they can be stopped by something as thin as a sheet of paper. So we're going to demonstrate this with our device. We start measurement. We can see the alpha particles hitting the sensor, and then when we insert a piece of paper between them, all the alpha particles are cut off. And you can see that also in the graph. When we put it back, all the particles are back. We can try to shield half of the sensor. We can see that the part that is shaded by the paper does not detect any alpha particles. Now, paper is known to stop alpha particles, but what about something else, like the cling film we mentioned earlier? Let's see if we start measuring again. And then we insert the film between the source and the detector. We can see that there is significantly less alpha particles, but they are still going through the film. When we try to shield half, we can see there's no clean edge like there was with the paper. And even when we look at the numbers, we can see the number of particles went down when we inserted the film, and then it went back up when we took it out again. And another kind of shielding you can try is with the bubble blower. So we set the source a little farther apart from the detectors, just so there's space for it. We start measuring. We see the alpha particles coming in, and then we carefully insert the bubble blower with the bubble in it. And we can see it shields the particles quite effectively. But then as we keep watching, we can see that the amount of alpha particles that come through becomes higher and higher. And that is because they become thinner and thinner, and they let through more and more of the alpha particles until eventually we see that the number goes quite high and almost reaches the point where it was before the bubble. If you have your own MiniPIX EDU detector or the whole Edu kit, you should visit our wiki, where we offer a list of experiments you can do with the detector and the whole setup.